I will present the concepts of dependability today, and I will provide an introduction to the taxonomy of dependability and dependable system design. Within the teaching project, we are aiming towards building the concept or creating the concept of humanistic intelligence, which has the goal that cybernetic and biological identities cooperate together in the context of cyber-physical systems to reach a shared goal. And we try to put the human into the center and try to capture or incorporate the human feedback in order to adapt the cyber-physical system, which should be optimized by the capabilities offered by human intelligence. And today I will introduce the taxonomy of dependability and secure computing at the beginning, and then I will explain how we can build dependable systems by an example. And then we try to extend this example by integrating an AI-based system that controls the entire system. And of course, the goal is to do that in a dependable manner. So to start with the taxonomy of dependability. Dependability is a concept that is built up of certain attributes, and those attributes are listed here. So dependability is a concept that's built up from availability, reliability, safety, confidentiality, integrity, and maintainability. And security is not explicitly mentioned as a part of dependability, but security, of course, is also a concept that's a set of properties of dependability. So security is built up of the properties of availability, confidentiality, and integrity. To give you some, to get a better understanding of the properties of dependability, I've prepared some examples. So the definition of availability is the probability that the system can perform its intended function when it's required. So we want to deliver a certain service, and if the system is capable of delivering this service in a correct manner, then the system is called available. And for example, we want our emergency braking system to work always in a case when an emergency happens. So we want to work the system whenever we are driving, and you can also think of that our system is available 24/7. The next thing is reliability. The key factor that's also in here is the system must be available, but reliability is the ability of the system to deliver continuous correct service. So this means that if we build a system, we can rely on the system that we always, if we give a certain input, the system behaves as expected over a certain amount of time. So as example, we have provided here the steer wire. We always want that our system reliably steers to the left if we give an input signal to steer to the left, and not that our system steers at a certain point of time to the right or does not steer. When we talk about safety, we want to reduce the probability that the system gives damage to the user or its environment. So we avoid damage to the user and the environment. And in the context of automotive systems, we can think of the vehicle safety measures. So we build in certain equipments and do certain designs of our systems in order to avoid fatal consequences to the human and the environment in case of a failure or in case of an accident. And when it's coming to confidentiality, this is an security property, we say, okay, this is the ability of a system to prevent unauthorized entities to access information. So if we have a keyless go system, for example, we don't want other people to get access to our car, and we only want those to get access to our car who are allowed to, so who have the credentials for accessing the car. And the system avoids the credential theft. Integrity is the ability of the system to protect data from unauthorized changes. So, for example, when we think of the Jeep Cherokee hack, we did not want hackers to override the commands within our car, but of course they could achieve this by hacking the Jeep Cherokee. And if we ensure integrity of the system, this is no longer or should no longer be possible. When we talk about maintainability, it is the ability of the system to perform successful modifications or repair actions during development and operations. So we want our system to be maintainable all the time. In the automotive system domain, we speak about over-the-air update functions, and this should provide us the ability to fix potential errors in the system or to provide new features if they are required. So if we refine that a bit, as we can see here, there are certain properties which are dedicated to dependability, and there is one property which is for explicitly dedicated to security. But availability and integrity are also dedicated to security. But if we talk explicitly about security, we mean with availability not only the readiness for correct service, but with availability we want to prevent unauthorized withholding of information. So nobody should get should be able to hijack our system, for example, to stop the service of the system. When it's coming to confidentiality, we want to prevent the unauthorized disclosure of information, and we also want to prevent that we can, so with integrity, we want to prevent that unauthorized people can alter information or delete information. And all these concepts from a security point of view can be summarized that we can only perform authorized actions on the system. Okay, these were the definitions about dependability and the terms which are related to dependability.